of these. And again, just a quick reminder, when we're looking at the inverse sine, the inverse cosine, and the inverse tangent. All right, so when you're talking about these inverse trig ratios, the inverse sine is going to go from negative pi over 2 to pi over 2. So we can look at it in this way, right? So here's negative pi over 2, and here's pi over 2. But that is the quadrants 1 and 2, or sorry, 1 and 4, is where the inverse sine is going to exist. The inverse cosine will exist in quadrants 1 and 2. So from 0 to pi. And then finally, the tangent is going to also, just like sine, exist in quadrants 1 and 4. Okay, so once again, from negative pi over 2 to pi over 2. And so knowing these is going to be needed in order to work through problems that look like this. Okay, so let's talk through a couple of these. Okay, if we look at this first problem right here, if you want to evaluate the inverse cosine of the cosine of pi over 2. Okay, so think about what you have on your unit circle here. Okay, so what is the cosine of pi over 2? Okay, so here's pi over 2. The cosine is the x-coordinate, so that is a 0, right? So now we're going to take the inverse cosine of 0. So now what we need to do is we need to look at this cosine graph. And which of these angle measures between 0 and pi has a cosine of 0? That would be this angle, which is pi over 2, right? Now, would it make sense here that you take the inverse cosine of the cosine, that you would just kind of pull that angle out, right? That kind of makes sense. Okay, but that's not always going to be the case. Let's look at the one right below that. I want you to try the same process here, but with this problem. Okay, I want you to find the cosine of negative 2 pi over 3, and then evaluate what angle has that particular cosine when you evaluate the inverse. If you rotate 2 pi over 3 in the negative direction, you get this angle right here. Okay, and so what we want to do is we want to find what is its cosine. Well, the cosine is its x-coordinate, right? And so if we are evaluating which angle has that particular cosine value, we have to look at the angles from 0 to pi, right, because it's the inverse cosine. And this angle, since it'll have the same x-coordinate, okay, or cosine as this, what we can see is that this angle right here is the angle that we're looking for. Okay, so this angle right here is going to be the same measure, but in the counterclockwise direction. Okay, and so that's going to be 2 pi over 3. Okay, and so that would be your answer for that problem. Okay, so what you'll need to be able to do is evaluate in that sense. Okay? Can you find the measures of the cosine, and then where does that sit on the unit circle for the interval for which the inverse is defined? Okay, let's look at this last example here. Again, I want you to see if you can evaluate this using the unit circle and the interval for which the inverse, in this case again cosine, is defined. Take the sine, cosine, or tangent. You're looking at the values on the unit circle for the x and y coordinate, or in terms of the tangent, the y divided by the x, or sine over cosine. When you're looking for the inverse, you're looking for what angle has that particular measure as its ratio. Okay, so here, if you take the inside here, sine of pi over 6. Well, pi over 6 is this 30 degrees, right? So that gives us a root 3 over 2 for the longer part and a 1/2 for the shorter part, the legs on those right triangles from that 30, 60, 90 triangle. So when you're looking at this, the sine is your y-coordinate, so we know that this is 1/2, right? So we're really evaluating the cosine, or the inverse cosine of 1/2. Okay, and so now we do need to shift gears a little bit because we want to find which angle has a cosine of 1/2. Well, here the cosine of 1/2 is going to be at this point, right? 1/2 and then √3/2 from the unit circle. And which angle has that given measure? It's going to be 2π/6, right? Which is π/3, and that would be your answer. So here you're not just using the visuals, you actually need to know what points correspond on the unit circle, find what they are, and then evaluate using, again, the values of the unit circle to identify which angle has that particular cosine. All right, so what I want you to do is I want you to try this middle row. Okay, so try the 3 questions in this middle row. All right, so when you're looking at this first one, π/3 exists right here in quadrant 1. Again, it's 60 degrees. Okay, and so this is what we're looking at. And so if we think of that as being that angle, or that particular measure, when we find what is the inverse tan, what angle has that particular tangent? Well, the inverse tangent is defined in these 2 intervals, right? Or in these 2 quadrants, 1 and 4. This angle already exists there, and so your answer is simply going to be the given angle of π/3. Now, if we take a look at it in this next example, though, we take 7π/6. Well, 7π/6, when we find that, rotates all the way past pi, okay? And so this is 7π/6. And so what we would need to do is when we evaluate which angle has the same tangent as that, well, the tangent is sine over cosine, means that we're going to create it using this reference triangle right here. And so you can find the other triangle that has the same tangent, a positive tangent, only exists in quadrant 1 and quadrant 3, right? The negative tangents exist in quadrants 2 and 4. And so here's the only 2 possible quadrants, so we need to use this same reference angle as we have in the 7π/6. And so this, to rotate back to the x-axis, is 1π/6. That means the corresponding piece here is also going to be 1π/6. Okay, and so that would be your measure. And then this final example in this column, the cosine of pi, so here's pi right here. The cosine for that is -1. Okay, and so what we're doing is we're evaluating what angle has a sine of -1. Well, our sine is defined in quadrants 1 and 4. So the angle that has that given sine of -1 is this angle down here. And now, if you answered 3π/2, you're not using the domain and the interval for your inverse function. The inverse sine is defined only from -π/2 to π/2. So when we look at this angle, we have to use the -π/2 to identify it. Okay, so be careful. If you put 3π/2, you have the right location, but it needs to stay within the domain of that interval, or of that inverse. All right, so try this last column, please. See if you can evaluate those last 3 expressions. All right, so if we look at these first, sine of π/4, well, π/4 is this 45 degrees right here, so there's your original angle. We want to find what angle has this given sine. Okay, so the sine is the y-coordinate. You could specifically find it, right? We do know that this is √2/2. So we could say what angle has the inverse sine of √2/2. But we also see that that is right in the domain of your interval. So it's just going to be that same measure, π/4. Okay, now that's a little bit different when we look at the next problem. 5 pi over 6, again, that's going to get us all the way to this angle. Okay, where we have this given sine as the height, the y value. So when we find what is the angle that has that same corresponding sine, we need to look in quadrants 1 or 4. And that's going to be right here in quadrant 1. And so you're going to move over this reference angle. So 5 pi over 6 has a reference angle of pi over 6. And so when you move up to find this, it's also going to be pi over 6. Okay, and so that would be your answer for that problem. And then the final example, again, when you have different sine and cosine, here is your pi over 4. That has the point root 2 over 2, root 2 over 2. The sine and cosine are exactly the same. So here the sine of pi over 4 is root 2 over 2. And so if we evaluate what angle in the interval defined for your inverse cosine, which is quadrants 1 and 2, which of these angle measures is going to have a cosine of root 2 over 2, and we see it happens to be that exact same thing, pi over 4. Okay. The first one, we're doing this same process, except it's not with angles that lie on the unit circle. And if that's the case, and notice here that the inverse functions are on the inside, what you're going to do for something like this is you're going to set up a right triangle. Based on what you're given as the inverse ratio. Okay, so if I know that this angle right here represents, or the angle that's represented by this, if I create a right triangle, okay, since tangent is TOA, and it represents the opposite over the adjacent, this is giving me the fact that the ratio of the opposite side of 17 and the adjacent side of 8 is going to be used for this right triangle. You can then use Pythagorean Theorem to find your missing side. Okay, and so here I would use the Pythagorean Theorem, 8 squared plus 17 squared is equal to c squared. Solve what I have here. If I get, I'll use this calculator since I have it pulled up. Okay, so if I square 8, add the square of 17, I get 353. Extract the root. Okay, and so that is my hypotenuse. And so when I write my answer for the cosine of this, the cosine is ca. So adjacent 8 over hypotenuse root 353. So I would get 8 over root 353. And if you rationalize this, dividing by root 353 is like multiplying by that same radical and dividing by the number pulled out of the radical. And so this would be my exact answer. Okay? And notice it is asking for an exact value here, so it wants that radical form. Okay? And so once you use Pythagorean Theorem to find the missing side, you'll use trig ratios to evaluate. Okay? And so that's the process for these types of questions. Okay? I want you to try this second one. See if you can set that up and evaluate the sine of that angle measure. So the first thing I'm going to do is I'm going to rewrite that. Here's the reverse process of rationalizing, right? So multiplying by root 13 and dividing by, or root 313 and dividing by 313 is the same thing as dividing by root 313. So that I can rewrite as just this, 12 divided by root 313. If I do it this way, I can then set up my right triangle here with a given measure theta, and it doesn't matter which acute angle you label theta, everything's going to be relative to that. So my cosine, which is ca, adjacent 12 over hypotenuse root 313. So I can plug that in based on my given inverse. I can then use Pythagorean Theorem. So I get 12 squared plus b squared equals root 313 squared. 144 plus b squared equals 313. The root and the power cancel. If I subtract 144 here from both sides, get 169. Extract the root, and b is equal to 13. So once I find that missing piece, I can then evaluate. Here I'm looking for sine. Sine is so. So with respect to this angle, opposite 13 over hypotenuse root 313. And when I rationalize, that's 13 times root 313 all over 313. Okay? And so that would be your answer for that second problem. All right, I want you to try one last time. Okay, see if you can find or evaluate the tangent of the angle represented by that sine ratio. Okay, so the same idea, same process. 13 root 365 divided by 365 is the same as 13 divided by root 365. That's just using that pattern. And so knowing this, I can set up my right triangle with a given angle using sine, which is so. Opposite of 13 over hypotenuse of 365, or root 365. Okay, and then I can use Pythagorean Theorem to solve. So if I take a squared plus 13 squared equals root 365 and solve the resulting equation, root 365 squared here. So the square cancels the radical. If I subtract 169 from both sides, I get a squared is equal to 196. Extract that root, and I get my a value to be 14. And once I have that as 14, I can then go back in and solve my tangent, which is TOA, is with respect to my angle opposite over adjacent. And so opposite over adjacent gives me my answer of 13 over 14 for that problem. Okay. All right. Questions on that? So this brings up the last set of, or type of problems, and these are just applications of right triangle trig in story problems. Okay, and so looking at this, you need to know two things. You need to know the angle of elevation versus the angle of depression. Angle of elevation is the angle that is formed when you're looking from the ground up, or from down looking up above. Okay, so if I took if I was looking from this spot right here up to a spot here, and my eye level went in this direction, okay, that angle that's formed right there is the angle of elevation. Okay, now, if I started at the ground and I looked up, the angle of elevation is that measure. If I started up here, however, and I looked down, I'll change the color. Okay, so if I started up here looking straight across, and I looked down, this is called the angle of depression. Now, if you recall from geometry, when you have parallel lines like this and this, okay, so this line and this line are parallel, this angle and this angle are alternate interior angles, if you recall that phrase. Okay, and alternate interior angles of parallel lines are equal. What you see here is that the angle of elevation and the angle of depression are going to be the exact same thing, right? It's all just a perspective of, are you looking from the top down or are you looking from the bottom up? Okay, and so each of these problems, when they give you these pieces of information, you have to interpret it as that. Okay, so if you use an 11-foot ramp to load items into a van, so that ramp's going to look like this, and the length of the ramp is 11 feet. Okay, if the floor of the van is 3 feet off the ground, that means that here's the top of the ramp to get into that van is 3 feet. And they ask, what's the angle of elevation? Well, the angle of elevation is from the ground up, so it's this angle formed right here. Okay, so the first step in solving these is to accurately sketch the right triangle that corresponds to the information provided. Okay, so based on the given information, sketch your right triangle. Okay, once you sketch the right triangle, what you're going to do is you're going to set up a trig ratio based on the given information. So with respect to this angle, I have an opposite and I have a hypotenuse. So opposite and hypotenuse relates which trig ratio? Sine, right? So that way I can set this up as sine theta is equal to opposite over hypotenuse. Okay, once you set up your trig ratio, then you can solve for the missing angle. And the way that you solve for the angle is you use the inverse trig ratio. So if we know that the sine of theta is equal to 3 over 11, we can find theta, the angle, by taking and evaluating which angle has 3 over 11 as its sine ratio. So we are going to use a calculator on these. Okay, so here, if I take, and I do want to make sure I'm in degree mode. Okay, when I take 3 over 11, evaluate that, and then take the inverse sine, I get my angle to be 15.83 degrees for my answer. So 15.83 is going to be my solution. All right, so try this on the second problem. See if you can set up your right triangle, evaluate or use or find the trig ratio that relates the angle to the two pieces of known information, and then evaluate that on your calculator to solve for the unknown. Okay, so here's your tower. Okay, it's connected by this wire that's 16 feet long. And it's anchored 3 feet from the base of the tower. So this measure here is 3 feet. And we want to find the angle. Once you set up your diagram, you can then identify with respect to the 3 pieces of information. We have an angle, we have an adjacent leg, and a hypotenuse. So which trig ratio relates adjacent hypotenuse? Cosine. So the cosine of theta is equal to 3 over 16. Therefore, when we evaluate this, we can find theta by taking the inverse cosine of that ratio, and doing that is going to give us our solution. So 3 over 16, and then take the inverse cosine, and that would be our answer. So again, degrees is 79.19 degrees. Okay, and so final problem of the school year. Okay, so try this last problem here. Notice this last problem uses the other kind of phrasing in the other direction here. So if you have some boat, okay, and it says that the distance of a boat to a lighthouse, so that distance from here to here, let's call this the lighthouse. Okay, that distance is 165 feet. And the lighthouse is 72 feet tall. And you want to find what's the angle of depression. So that means that if you're looking from up here, straight across, and you rotate down to look at this boat, this is the angle of depression. And remember, that angle is exactly the same as the angle of elevation. So if you are looking for what is that angle here, we want to find this measure, we can simply find the corresponding angle of elevation, and that's going to give you the same measures. So with respect to the right triangle that we created, we have an unknown angle, we have an opposite leg, and we have an adjacent leg. Which trig ratio relates opposite and adjacent? TOA, the tangent. And so we get the tangent of theta is equal to opposite over adjacent. So if we're solving for our unknown angle, we'll take the inverse tangent of that ratio. And when we do, so again here we take 72 divided by 165, and we take the inverse tangent of this, and there would be our angle, 23.57 degrees. Okay, and that would be our final answer.